Hello, we are going to start here in a few minutes, just kind of get everything set up. We will begin shortly. All right. Let me go ahead and see if I can share my screen. That's always the true litmus test of this stuff. See if Emacs pops up. Oh, thank you. Oh, great. Okay, so it looks like we're able to share the screen properly. See if anybody's joined yet. And yes, we actually do have, a few people joining. So let me go ahead and get started. Welcome to the 4th virtual office hour for the POSA Communications MOOC. What I'm planning to do in the session today is go through my solution to assignment number 2 so that people who are still doing peer assessment can take a look if they have any questions. And of course, speaking of questions, I'm always happy to take questions. So if you have any questions you'd like to ask, don't hesitate to type them into the questions portion of the app. So without further ado, let's go ahead and switch over to Emacs. Okay, so this of course is the assignment. If you recall, assignment number 2 builds upon assignment number 1 by taking essentially the same client application, generalizing it ever so slightly, and then making it possible to be able to select between which implementation you want to use to actually download the image. In this particular case, or rather in assignment number 1, we used a started service, which we saw in my walkthrough last time, so I won't go through that again. In this implementation, we're going to use a bound service. Now, as you may recall, bound services have a somewhat more interesting protocol than started services because they have to establish the connection, and there's a bunch of hook methods that get called back, so you have to write that. And there's also, of course, 2 sides to these services. There's the client side part, which we're going to look at first, and then there's the service implementation itself. So let's start by going and looking at image model impl bound service. This is the part that plays the client side of the service. As you can see here, it's got a couple of messengers. It's got a reply messenger and it's got a request messenger ref. Those are the 2 things it's got. And it's got a service connection. Here's the service connection. This is one of the things you have to do. You have to implement this properly. This is the service connection that's going to be used after the binding is established, or it's a callback hook that gets invoked after the binding is established. When the binding is established, Android calls back to the onServiceConnected method. The onServiceConnected method goes ahead and makes a new messenger that encapsulates the binder that's passed back over here. So we're getting basically a messenger reference to a messenger object, and that messenger object actually lives over in the service side, the download service, the bound download service. So that gets set here. On service disconnected, it's simply going to set that reference to null, which indicates that we have to rebind before we can continue if that's appropriate. Here is the constructor for image model impl bound service. We go ahead and make the new messenger. That's the reply messenger. That's what's going to get sent along with the request, so that that will then have the information that's used by the service to get back to the client side of this equation, this client service interaction. Here's the bind service method. This, of course, is basically a hook method in the template method pattern, and there's different implementations. For the started service, it's basically a no-op. For the bound service, it actually implements the binding process. And this is a little tricky because you have to know what contexts to use here to make things work properly. So we take a look, we see if the reference has been set to null. If it has been, that means we haven't been connected yet. We then go ahead and we make a new intent using the make intent factory method on download images bound service. We can pass in the activity context for that, because that's just what we need to get connected. And here, things are a little bit more interesting. We go ahead and we use the application context from the image presenter, which ultimately gets back up to the application context for the activity. And we use that context to perform the binding. And the reason for doing this, of course, is because we want to make sure that the context that's used for the bound service will outlive any given application that, or any given activity that may come or go as things get rotated. So that's how we do that. That's the bind method. The most important thing here is you use the application context to do the binding. And here we have unbind service. This is kind of interesting. What we do here is, if the reference is not null, we go ahead and we unbind the service, again using the application context, which won't change for the lifetime of the application. And then we go ahead and set the request messenger ref to null, indicating that we're going to need another bind service next time. Here's the start download method. Start download method's called when we want to download something. And of course, multiple of these things can get called concurrently and simultaneously, so that they're going to be able to run in parallel, especially if you have a multi-core processor. And even if you don't have a multi-core processor, it's still a good idea, or still a win to do this kind of thing. And so what happens here is when start download gets called, we make a new request message, which indicates all the information we have to have here. And that's basically the factory method that makes the request message containing the URL we want to download, the path to store the result, the reply messenger, and so on. That all gets bundled as extras in the request message. And then down here, we go ahead and we use the request messenger ref to send that message. And that goes ahead and sends the message from the client part of the application to the service itself. So those are basically the key parts that you need to do if you want to implement the service, the client side of the service. Now go take a look and see how we implement the service itself. As you can see, we have two implementations. This is the one we looked at last time. This is the started service. Here's the bound service implementation. Okay, so download images bound service. It's a lifecycle logging service, so things get logged properly. We have a request handler that's going to be the one that handles the messages sent from the activity, or really it gets sent from the application. It's not so much the activity, from the client app, I guess is the best way to put it. And this is also getting sent from the client app, just changing the comments to make it more clear. The messenger is going to actually be the implementation in the service. This is what's going to reside in the service itself. A reference to this will get passed back to the client app. Here's the request handler. This is the guy that knows how to handle the stuff from a client app. And it's going to run this in a pool of threads. Here we use a weak reference to make sure that garbage collection works properly. We have the executor service. That's where we're going to get our pool of threads from. Here's the request handler constructor that makes a new service. And it goes ahead and stores that service as a variable. And then we go ahead and we make our executor service that will manage the pool of threads. And we're going to do this as a cached thread pool. This is all code that was given to you, by the way. Here's the handle message method. Handle message, as you probably recall. Again, this isn't coming from the client app. It's going to reply to the client app. And clear. So handle message gets called back when the client app sends the message from the code we just looked at. It's going to come in here as a message. We're going to convert that back into a request message, because that's what it is under the hood. And then we're going to use that request message to ferret out or fish out some of the fields that we need here. We're going to get the messenger, reply messenger. That's who we're going to send the result back to. We get the URL from the image from the message. We get the path name where we want the image stored. And we get the request code, which doesn't really get used here, but in a more interesting application would get used. We then go ahead and create a runnable, which is a final runnable. And its run hook method is going to go ahead and be called in a background thread running in the thread pool. and that will then go ahead and download the image, and that takes place in the background. So it's fine to make a blocking call here because it's running in a background thread, and that will then get the image, the path to the image file. And once we've got that file path downloaded and the image stored, we go ahead and send the path back to the client app. That's what we're going to do. We're going to take a look at that code in just a second. Here's the execute method. This takes the runnable we just made, sticks it onto the message queue, the underlying message queue that's used, or the task queue, I guess is a better term, for the executor service, which executes tasks. And when that task is run, of course, it'll go ahead and run the run method in this runnable to do the work and download things in the background. Here's the send path method. I guess I should point out here that handle message gets called. Normally this would run in the main thread of control of the service. And what we're doing here is we're redirecting this to run in a background thread by creating a task and a runnable to run that in the background thread. Here's the send path method. The send path method takes the various fields, the messenger to reply to. It takes the, I guess I should say, this is actually the reply messenger. Let's make it a little bit more clear what it is. It's a reply messenger. And we go ahead and make a reply message that uses the path of the image file, the original URL, and the request code. And that reply message is then going to get sent back to the client app, which is what's going on here. Client app. It's going to send that back to the client app. Now, of course, that will eventually end up in an activity, but more importantly, it's sending it back to the client app. So this is a messenger sending back the message portion of the reply message back to the client app. When things get shut down, that's going to tell the executor service to shut down immediately. You can also use shutdown. Either one of those should work. I like shutdown now because it doesn't wait around as long. It's a bit more impatient, but you can use shutdown if you want. And here is make intent. This simply makes an intent that will be used to launch the bound service. And here's the onCreate method. The onCreate method of the service gets called when the service is first initiated or first launched. That creates the new request handler. And then it goes ahead and it creates a new request messenger. And the messenger encapsulates the request handler. You can see that here. It encapsulates it. It stores it. Notice that the messenger and the handler always reside in the service implementation. They never get sent back to the client. Only a reference to them gets sent back to the client. Here's the onBind method. OnBind simply gets called back when the client app calls bind service. The onBind hook method gets called back by the Android Activity Manager service and the service framework, and that goes ahead and basically returns the binder for the request messenger and sends that back where it's stored on the client app, as we saw. And finally, when we're all done and the service goes away, the onDestroy hook method gets called back, and that calls request handler shutdown. And we just saw that request handler shutdown up here somewhere. Where did that go? Oh, here we go. That's this method right here, shutdown. That goes ahead and shuts down the service. So that's basically the implementation. Made a few little tweaks here just to clarify the role of the client app versus the activity. That's a holdover from an earlier implementation that didn't use the model view presenter pattern, but that's all been remedied, and wanted to make sure those things are consistent. Okay, so let's see if there are any questions. Okay, the first thing here, I'm not sure if this is a question or a comment. It says, the messenger is a wrapper around a binder, which is the class for a remotable object. The core part of the lightweight remote procedure call mechanism defined by iBinder. That is absolutely correct. So if you do assignment number 3, you'll see that we use perhaps arguably a more advanced form of interprocess communication using the binder framework via the Android interface definition language. And what we're looking at here is really the earlier version, or not earlier version, it's the lighter version, which is essentially the messenger. So that's basically the basic building block, and it has a thin layer atop the underlying message passing mechanisms available by the iBinder. Let's see, here's a question. I just evaluated other students' work, and one of the students made a copy of the reply message using Messenger Obtain. Let's see. Made a copy of the reply message. You can probably do that. I don't know if it's strictly necessary, but you can probably do that. It's probably fine. The one thing to remember about the handle message call is that things don't live beyond the lifetime of the callback. In fact, that's important enough. Let's go back and look at that code real quick just to make sure that everybody's aware of what I'm about to say, because this is pretty important to remember. Let's see. Let's go back to Emacs, and there's Emacs. All right, so let's take a look at handle message. Here's the handle message method. Now, the thing to remember here is that this message is going to get recycled as soon as the call returns. So we have to be careful here how we do this. What we do here is we go ahead and we grab the messenger, and we grab the URL, and we grab the path name, and we stick these into final variables, and we also grab the request code. And then we go ahead and use those things running in the background. Notice that we're not actually reusing the message per se. We're not reusing the message itself. We're using the contents of what was stored in the message, which in this case is the request message, the messenger, the URL, and the directory path name. So we've kind of pinned those things down using final. And of course, we have to use final because we couldn't use anything else other than final in order to be able to call this method in the background. So that's why we didn't have to make a copy of the message. We went ahead and we grabbed its constituent fields and we pinned them using final. So they're not going to go away out from underneath us, which is a good thing. So it's not strictly necessary to do that, but it's certainly it's not strictly necessary to use the obtain method to make a copy of the message, but you could if you wanted to. Another good question, is AIDL used in real production projects? Yes, absolutely. In fact, if you watch the videos on AIDL, if you take a look at the videos that are part of the course, you will see that I go through and show examples of where they're used in Android, and I think I actually have a slide where I give some examples of where AIDL is used. AIDL is used absolutely everywhere in Android and other places. In fact, let's see if we can do something amusing here just to demonstrate the point. Give me 1 second. I'll see if I can get this to work. Let's see. Let's go into Android and we'll go into frameworks. All right. So I'm going to share my screen here. It's just for kicks. Let's go over here and let's see if I can share my desktop. All right. So I'm in the Android frameworks code. Hopefully you can see that. I'm going to go ahead and search for anything with AIDL, and I'm going to print it. And so this is the source code for Android itself. This is all the code that you would get in the Android release. So I think we'll hopefully all agree that Android is real production code. And as you can see here, as these AIDL files go whizzing by on the screen, that AIDL is used extremely heavily within Android. This is the Android frameworks code. And it's going on and on. There's literally hundreds of uses there. Let's go over to packages just for kicks. Let's see if we can find any uses of AIDL in the packages portion of Android as well. So it was certainly used in Android, the framework, and now we're taking a look at the packages. So you can see it's being used in email. It's being used in the media playback service. It's being used in near-field communication, in TV settings. There's something called experimental. I'm not quite sure what that is. It's used in providers. There's a bunch of uses of it in services, the network query service, the media provider, and so on. So you can see that it's very heavily used in Android. In its framework core, it's used in a bunch of the packaged apps that come bundled with Android. So yes, I think it would be fair to say that AIDL is used in real production projects. Great. So does anybody else have any other questions? So just to give you a little roadmap of, while we're waiting for people to type in any questions they might have, just to give you a little roadmap of what we're doing. Really what's left at this point is pretty much the third programming assignment, and that'll be done. I think that's due in about a week and a half or so. Don't trust my intuition on that. Take a look at the course website and see when the due date is. And then you'll have a week to do peer assessment on that. And of course, we'll do another virtual office hour to go over my solution to assignment number 3. You are, of course, under no obligation to do the same, use my solution as the basis for assignment number 3. That's what makes them mini projects as opposed to regular assignments. You can do whatever you want with them. But that's what the last assignment is. And then I think after that, I think the class wraps up at the end of the month or so. And then the next MOOC begins in early February, and that'll be the POSA Content MOOC. There's been a little confusion about this, and I apologize for that. The basic idea is that POSA Content is an optional MOOC with respect to the specialization. If you start the specialization that started with Adam Porter's course, 2 courses several months ago, you don't need to take POSA Content, and you can still get in, you can still complete these other MOOCs successfully. You can take the capstone, etc. I strongly recommend you take POSA Content because it's going to be full of some cool stuff, and we'll cover some really interesting and important parts of Android having to do with content providers and SQLite and other mechanisms like retrofit and ways of accessing web service databases and so on. But you don't have to take it for this go round. Subsequently, if you or other people were to take the specialization in the future, when it reboots here soon, hopefully fairly soon, then it will become a required course. But it's not a required course at this point, so it's up to you whether you want to take it or not. I strongly recommend you take it because it covers very important material, but it's not required. And I'm talking to the Coursera folks to make sure that their messaging and customer support is correct. They seem like they might be a little confused, but that's okay. We'll get it clarified. Don't worry about that. Okay, well, it doesn't look like there's any other questions. So thanks again to everybody for joining. And this video will go up on the website not too long from now. Thanks very much.